Exercise 1.2. Question 1. State whether the following statements are true or false. Justify your answers. The first given statement is every irrational number is a real number. The answer is true, because real numbers contain all rational and irrational numbers. So it is true that all irrational numbers come in the set of real numbers. So it is correct statement that every irrational number is a real number. Now, second statement given to us is every point on the number line is of the form root m, where m is a natural number. Now look at the number line. A number line has positive numbers on the right side of 0, like 1, 2, 3, 4, 5, 6 and so on, and on the left side of 0 it has negative integers, -1, -2, -3, -4, -5. Now this point can be expressed as root 1, because root 1 is 1. This point can be expressed as root 4, because root 4 is 2. This point can be expressed as root 9. Root 16 is 4. Root 25 is 5. So on the right hand side, the point on the number line on the right side can be expressed in the form root m, where m is a natural number. But on the left hand side we have negative integers, and because these negative integers cannot be root of any natural number, so this statement is false. So our answer is false, because the points on the number line representing negative integers are not square root of any natural number. Now, third statement is every real number is an irrational number. Every real number is an irrational number. This statement is false because real number contain both rational and irrational numbers. So the real numbers which are rational are not irrational. So this statement that every real number is irrational number is false. Converse of this is true. Every rational is real or every irrational is real. But if we say every real is rational or every irrational or every real is irrational, these statements are false. Now, question 2 of the same exercise 1.2. The question is, are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Now under root 4 is square root of a positive integer which is equal to 2. So is not an irrational number. So our first answer, that are the square roots of all positive integers irrational? No. Square root of all positive integers are not irrational. An example, we have started with the example. Other examples are like root 9, root 16, root 25, root 36. All these square root of positive integers are not irrational because their values are rational numbers. 3. Root 9 is 3. Root 16 is 4. Root 25 is 5. Root 36 is 6. But other than this, the square root of non-perfect square positive numbers like root 7, root 5, root 15, etc. are irrational numbers, but not all positive integers. Now question 3. Show how root 5 can be represented on the number line. So let us first draw a number line. Mark these points at equal distances. It's not necessary that you draw a number line in which every point is at a distance of 1 centimeter. You can take a distance of 2 centimeters to mark every point. It will be comfortable to represent root 5. So let us take this point 0. This is 1. This is 2. This is 3. 4. Here we have -1 and -2. Now we know this distance from here to this point is 2. 2 is root 4 actually. So let us draw a right angle at this point. This is 60 degree. Now from 60, next arc is of 120, and now bisect this 60 and 120, you will get a right angle. You all know how to draw a right angle using compasses. Now in your compass, measure this 1 unit from 0 to 1, this one. After measuring it, put your compass needle on 2 and cut an arc on this vertical line. Let this point be A and let this point be O. This is O. This is 0. Now join OA. This OA, let this point be B. This OA is root 5. We can simplify this also. In right triangle OBA, in this right triangle OBA, we are applying Pythagoras theorem. This is hypotenuse, so OA square is equal to perpendicular AB square. This we have drawn equal to 1 unit plus OB square. This is by Pythagoras theorem. Now OA square is equal to 1, AB is 1 square, and this OB is 2, so 2 square. So OA square is equal to 1 plus 4, that is 5. So OA is equal to root 5. Now this is the justification why this length is root 5. Now let us mark this root 5 on number line. So for this you stretch your compass equal to this length. Put it on O and stretch your compass till point A. After measuring it and keeping it on O, just take it down and cut the number line. This point represents, let it be C. So this length, whole length OC is root 5, and this point C represents root 5. So here we can write that OA on number line, this OC is root 5. So this is the solution of question 3 of exercise 1.2. Now the last question. This is an activity, I am reading it, classroom activity, constructing the square root spiral. So I am telling you, or I am drawing here the square root spiral. So for that you need a scale and D. Let us first draw a line segment of, I am taking here 2 centimeter and I am considering it as 1 unit. This, let us give the name to these vertices. Let it be O P1. And now at this P1, draw a right angle. this is the right angle. Now on this vertical line, first measure this 1 unit in your compass and cut this vertical line. Let this point be P2. Join this P2. Since this P1, P2 is also of 1 unit, by Pythagoras theorem you can easily find out the length of OP2. It would be root 2. Now place your D on OP2 like this, and again draw a right angle from this line OP2. So this is the vertical line from this OP2, and you already have this compass in which you have measured 1 unit. Do not change this and put it on P2 and again cut this vertical. Now this is again of, let this point be P3. This is 1 unit again. So if you are going to join this OP3, you will get root 3. Now again, for root 4, you put your D on OP3 like this and make a right angle. This is a vertical line to OP3, and again that 1 unit and put it on P3 and cut this vertical line. This will be P4 and join OP4. This OP4 is root 4, and again on this OP4, if you repeat the same thing, now put your D on OP4 like this and again make a right angle, and this is the vertical line to OP4. You have already measured this 1 unit in the compass and put it on P4 and cut this vertical line. This is P5 and join this OP5. This OP5 is root 5. So in this way this spiral can be drawn, or you can continue with this. After this you will get root 6, then root 7 and so on. This completes our exercise 1.2.